All right, so we're going to go over the free response portion of the 2015. So we did R prime of 45 should be this, which reduces down to -3/2. Now this is interesting. What the heck are the units? Because this is liters per minute. So that's liters per minute squared, or you could say liters per minute. And they actually accept that answer just fine. Now, when it says to explain what that meaning is, you would say the rate that the water is being pumped at. Now, careful, what is happening? This is the rate at which the water is being pumped. Then what are we saying? Yeah, the rate at which the water is being pumped out at 45 minutes is decreasing at -3/2 of a liter per minute. Now, the reason I went over that like statement, and I decided not to write it since you probably wouldn't be able to read what I wrote anyway. But I wanted to say that out loud because on the test and on my final exam, you don't just say it was decreasing by -3/2. You have to say at 45, right? That the water pumped is being, so that full explanation is important. So for part B, how many liters have been pumped into the tank at that value? So what we need to do is we need to take out this thing, and how do we figure out the quantity of water that is actually pumped into the tank? We're going to take an integral. And so what I did is I said, well, the integral from 0 to 55 minutes of R of t dt. Now, unfortunately, that's nice to write, but we don't have the equations, although I guess we could if we wanted to. What was the easier way to find that integral? What's the easier way? Just geometry. Let's just find all the areas. So what's going to happen in here is I drove this sucker right down here. Come on in, ladies. I drove that in as it is. Welcome. Good morning. Feeling good? Great. Happy days. And you good? All right. So what is happening here is we've got a trapezoid, right? So the trapezoids that you guys used to do back in both elementary school as well as like your math too, usually were not oriented vertically. In calculus, they're all oriented vertically, so that causes trouble for people sometimes when they have them oriented this way. So we would call this one base, this is another base. So the formula for a trapezoid is base 1, 10, plus base 2, 30, divided by 2, times the thickness. Well, how thick is this trapezoid? It's 20. Now, this is the portion, I believe, where you can have a calculator, but you really kind of don't need it because they made them pretty nice. Now, the next piece, I have to admit I made a mistake and then I had to go back and fix it because I was a little cavalier. I came up here to the 35 and I dropped it down to the 40. Be a little cautious. It's right in the middle. So this is just a simple rectangle, base of 15 and height of 30. 15 by 30. And the last piece, what shape is this guy right here? Is 1/2 base times height, right? Where the base would from 35 to 55 is 20. And its height was 30. And putting it all together, I think we got 1,150 liters. Okay? So that's kind of what should have happened on number 1, part B. Now, as you go through that, of course, this is talking about the pump, right? The mistake that a lot of people would say is that there's 1,150 liters in the tank. Is that true? No, it says 1,150 liters were pumped into the tank. That's all we know. Could the tank have been empty at the get? Absolutely. Could it have been mainly full and somebody else could have been pulling water out of it, right? Does that happen? In fact, what I will say is we have a pressure tank at our house, right? We have a well with a pressure tank. And all the time when the sprinklers go on, what happens is there water in the tank? Absolutely. And then once that pressure tank starts running, the pressure in the tank will start dropping, and then the motor on the well kicks on and starts doing it. And we try to time it to keep all of that stuff in balance so the pump doesn't go on and off and on and off. Because if you learn someday, hopefully some of you have property and all that kind of stuff. If that happens, you know what happens if your well goes off and on? You get to buy a new pump. And it's only a couple $1,000s. It's really not that big of a penalty. It really sucks. So you time it to where when your sprinklers come on or you're using stuff to water your garden, you put enough water on there so the pump just runs continuously until it's done needing to do that job, and then it shuts off 10 minutes later, something like that. So in the next part of the question, let's go on here. In the next portion of that question, part C, let's keep moving here. It says at 10 minutes, so they waited a little bit and then they started draining some water. In other words, they're going to irrigate the field. So they waited 10 minutes. And it says they started draining water. So if it's draining, what's happening? We're going to start losing. So what we have is at 10 minutes, we started draining. So from 10 to 55, we are losing it at d of t dt, which of course, if you want to literally write that down, you can, but you do not have to. But what else do I have in my story? But then there was also the 1,150 liters that were pumped into my story, weren't there? At 55, that's the end of the story. That means all this stuff drained between 10 and 55, but there was also an additional 1,150 pumped in. But there's something else. What have we still not discussed? Where did it start? And when you did this whole thing way back at the very beginning of the problem, I believe it told us. There it is. It says at time 0, the tank had 100 liters in it. Where does that go? Out front. So I started at 100. I started losing some, but I gained a bunch. Now, do I actually have to do this math? No, let the calculator do all that stuff. And so you're going to get 799.725 or 0.724, depending on how you round it. And that's going to be the amount of liquid that is in the tank when it's all done, roughly 800 gallons, right? Or 800 liters. Now, part D, using this thing, determine whether the amount of water in the tank is increasing or decreasing at 45. Now, that's kind of interesting. So what is actually happening? So the question is, what was R of 45? So R of 45 is what's happening to the pump, right? What is D of 45? How much is going out at that moment, right? So now the interesting thing is do we know what R of 45 is? Well, we kind of almost had to figure that out a while ago because R of 45 right here, I guess this is just my work. I went back and I said, well, shoot, if from here to here, 45 is smack dab in the middle, isn't it? So where I guess the 15 should be smack dab in the middle of 0 and 30. So this was 15. And then I went to my calculator. Now D was this equation right here, right? So I'm going to plug in D of 45, and I did, and I ended up with 10.881. So what would that tell you guys? Who's bigger, what's being pumped in or what's being taken out? Pumped in. So this is clearly larger. So if they're saying, is the amount of water in the tank increasing or decreasing at this moment, what would you say? And so we're going to be very, very flippant. We're going to say the amount of water in the tank at 45 minutes is increasing because R of 45 is bigger than D of 45, or because 15 is bigger than 10.881. More is being pumped in than is being taken out. So that was question number 1. Now I'll have to kind of go over how we score that. So I'll bring that up so you can actually see the score proposal on that thing. So you can kind of see, because I think a lot of you probably would like to give yourself an actual value there. So here we go. Let's go ahead and do a new share to this so you can actually score yourself. So r prime of 45 being negative 3/2, and then did you explain it? 1 point for each. Then they gave you the sum of the areas and then the answer, which is kind of funny because effectively what they're telling you is they're saying, did you break it into chunks and go out and get those chunks? And then one for the answer, which of course is just adding those together. This is kind of an interesting thing because if you went through this and you made a mistake in one of these 3 places, could that happen? And then could you correctly find your 3 regions and get the wrong answer because you made an error in one of those? As long as your work is reasonable, they'd still give you the second point to follow along. Like, let's say you went and did something silly where you didn't drop that line vertically, like my original, like when I first started the problem, I didn't see it and then I had to go back and fix it. I could still get one of the 2 points. So you just have to be reasonable. Now here they give you a point for your integral from 10 to 55, one for the expression of water in the tank, which is the 100, and then one for the answer. So they wanted to see all of this right here. That's that second point, and then once for actually executing that on the calculator. And this one I thought was kind of funny because they said 2 points, period, for answer with justification. And that left me a little hanging because I know what a 2 looks like, but I don't know exactly if you can even get a 1. In the grading seminars, they would talk about that and say whether they would, let's say somebody found out what D of 45 is, and they probably would give you 1 point if you got most of that correctly, but maybe you executed the final decision wrong. I don't know, but they don't say in that. And so I would have to interpret. So this next problem is the reason I decided not to have volunteers, because I do think that I probably could have had some of you come in here and actually do some of these, but this problem right here was kind of a booger. It kind of was. Now, does that look like kind of a scary looking graph? Yeah, and we did some of those kind of graphs when I even remember the name of the assignment. I called it Famous Curves, where we were looking at the Witch of Agnesy and Folium of Descartes and all that kind of stuff. And I was having you play with a lot of those things. But this problem right here, it looks a little spooky. So we've got dy dx now, but keep in mind also that this is calculator active, right? So when we look at this thing, and I want to know the tangent at point P, where point P, the x coordinate is 2. So I need to figure out what the y coordinate is. So the first thing I need to do is I need to look up here and say if x is 2, then what I have is 4 equals -2 plus y plus 5 cosine y. Now, again, some of you are like, I don't know how to solve that. How do I solve it? No, honestly, how do you solve that? Put it in your calculator. That's all we had to do. I had to just come into here. Let me fix my machine because the other class is doing something weird. We're just going to write 4 as one of them. We're going to write -2 plus x plus 5 cosine x. No, we can't use y. In terms of my window, what kind of y value am I looking for, everybody? I mean, my window's jacked, but it looks like my x values are like -4 to 4. And my y values go from about -2 to about 10, don't they? So if I go like this, I must have messed something up. Something missed. Yeah, because I didn't do the negative x. Did that right. Oh, that's why. -2 to about 12. Sounds good to me. So this is what I've got. Maybe. Ooh, hold on. Did I do something wrong? 4, and I got -2 plus x plus 5 cosine x. Did I not go into make the window a little bit bigger? Let's go up to 15 maybe. On the x side. Because I actually did this problem before and I actually got it. Oh, that makes sense because it's now the y. Oh, stupid, sorry. Yeah, okay, it's all mixed. Did I make it big enough? I think it did. There it is. So we're going to calculate that intersection, which we've done a few times before. Now, this is a little bit irritating because remember the protocol is we have to keep good accuracy. So I got 4.9283. Now, the deal is for my final exam as well as the AP, whichever one you are, we're going to take this thing and we're going to store that answer as alpha A because we're not done. I now need to plug that in right here. So what is dy dx evaluated at this coordinate? So what are we going to plug in for x, everybody? 2, so 2 times 2 is 4. 1 minus 5 sine of that value, which I called a, right? So I don't really have to do all that work. I'm just going to do 5 divided by 1 minus 5 sine a, because I stored it. And I got 0.6798. So now keep in mind, that's my slope. Now, guys, do I have a point and do I have a slope? Well, that being stated, then how do I write it in point slope form? Y minus the y value equals m times x minus the x value. And should we rewrite that in slope-intercept form? No, leave it alone. Life is good. That's a hard problem, isn't it? That's kind of a weird thing to throw at you because you not only do you have to remember that you're going to have to use x instead of y and tweak your windows and all that stuff, but then you're also going to have to remember that you're going all the way to that tangent line. So now for y is less than or 11, find all the values where the line to the tangent is vertical. Okay, so this is a little bit of an interesting thing. If your derivative is 2x over 1 minus 5 sine y, where is the derivative, where is that tangent going to be vertical? What do you have to do? You have to have a 0 in the denominator. So we just need to do this. We need to set that equal to 0. Now, guys, what would be the valid window for y? Be careful about this. For y, according to the graph, it's going to go somewhere between maybe -2 and about 12, right? But that's going to become x, right? Because we switched. So we're going to go ahead and do 1 minus 5 sine x. We're going to go ahead and make my window go from maybe -2 to about 12 for y, and I'm not going to worry too much about this part. So here's where it hits. So how many places does it hit x equals 0? I see 1, 2, 3, 4. So it appears that there are 4 places where the tangent would be vertical. And so just to save us the time, I think you guys know how to do that. So do you guys know how, careful everybody, do you guys know how to find those zeros? There's 2 ways to do it. One is you can calculate the 0 and go left to right and enter. The other way is to plug in y equals 0 and then find out where they cross, okay? Finding where they cross is probably the easiest way. But when I did it, I got the following answers, 0.2013, and it says just the y part, right? Then I got 2.940. Then I got 6.485. Then I got 9.223. However, check out those answers, but then look back at the picture that you were provided. Does 0.2 make sense for y? Does this number right here, does it sound plausible that that was 0.2 units up? That does. Does the number 9.2 seem plausible? Like right here, does that seem plausible? What about this guy right here? What is that about? That looks like somewhere around 7, so that makes sense right here. But what about 2.94? No. Oh, it doesn't even exist in the dang graph, so we're going to go ahead and toss that. It's not in the domain, right? So what's weird is although it seems like that y value is a possibility, it actually did not exist actually in the range of this particular problem. It just couldn't be there. And then the last one is, how do you find the average value? That is just like neon sign, like how do you find the average value? So there's a formula. The formula for the average value is 1 over b minus a integral from a to b of f of x dx. This is the formula that we did back in the day. So how big is the interval of which we're speaking? So it's going to be 1 over 4. Integral from where to where? From 5 to 9. And now we're finding the average value of the x coordinates. Well, if you go all the way back to the beginning of the problem, which is one of those mean things that they do, look what it says x is. It says x squared equals all of that stuff. So what is x itself? Oh, the square root of it. So we've got the square root of negative 2 plus y plus 5 cosine y dy. Now, if you wrote that down, you're going to be good, because do you guys have the ability to integrate that thing? I don't, but with my calculator, I'm happy. I can do that, and I got 2.550. Okay, so in terms of scoring, let's go ahead and take a look at our scoring rubric. So here's where the scores come from. So in the first one, if you got the y coordinate, because you had to find this 4.92 whatever, you got a point for that. You also got a point if you correctly stuffed the x and the y both in there to get that slope. And then you finally got a point if you could actually execute putting these two ideas, the slope and the point, together. I'm actually rather surprised they gave you a point for putting those two together, because once you have the first two, the last one should be fairly automatic. Okay, letter B. You got a point if you set 1 minus 5 sine y to 0. And this is a little interesting. They gave you 2 points for the coordinate. And I'm guessing that they would take off 1 if you listed that extra point that should not have been there. So they'd probably give you 1 out of the 2. I have a feeling there's some flexibility in this, but I don't know that for certain. 1 point for your integrand, 1 point for the limits and the constant, and then 1 point when you executed that in your calculator. So they do give you a point for hitting FNINT and going for it. But you notice that they didn't write FNINT, right? Don't ever write FNINT, because that's Texas Instruments speak, that's not math, okay? So don't ever write that. That kind of actually makes them irritated, which means me too on your final exam, okay? So you guys doing okay so far? So give yourself a score out of 9 on both of those first two. And let's see what we can do from there. Let me kind of reshift, because I have the test in different sets. So let's go ahead and shift over to the other part. And let's see, I think this might be a part that you felt a little bit more comfortable with. So we're going to shift back to here. And that one I thought was pretty hard, so I just kind of wanted to direct. But you guys tell me, what do we want to do for Kathleen to find her acceleration? Who can tell me how to find Kathleen's acceleration? I know you guys, I think a lot of you worked together on this, did you not? I think that's what I saw. What do you guys think? What is A of t? Somebody volunteer. What are we going to do? 10 minus 5 over what? 5 minus 3. So we are looking at 5 halves. Now let's be careful about the units. What would the units on this be? Because you took feet per second. And then per second, so it'd be feet per second squared. Now it says, let's do that. And by the way, that is at t equals 4, right? So at t equals 4 seconds. Was this the precise value, or is that an approximation? This is actually technically an approximation, isn't it? But that's the best one that we can have because we don't have a model of the data. All we have is specific data. Now, using Wright-Riemann sums, I think you guys like these. So a Wright-Riemann sum, what's the first rectangle we would have then? Now let's be careful. Which one's the input and which one's the output? Looks like the T is my input and this is my output, right? So how tall is this first rectangle? It should be 5. And how wide is it? It should be 3. So you should have had 5 by 3. What's the next one?
2 by 10.
2 by 10. Yes, it is. The next one was 3 by 20. The final one was 4 by 24. And I saw some of you goes, oh, dang it, I don't have a calculator and I got to do those things. Yeah, shoot, 24 times 4. Anyway, that kind of sucked. Yeah, that is kind of mean, but I think it's 191. Now again, careful about this. What would the units be? It depends. Yeah, you could write 3 times 5, 5 times 3. It's the same thing. Yeah, it's 191 what? What's the unit on it? Feet. Absolutely. If you take feet per second times seconds, that's feet. Now it says explain what happened. Is this going to be an under or an overestimate? So keep in mind, they told me that the graph is going uphill and we use Wright sums. Did we not? So what's that going to say then? It's an overestimate. And you don't have to say anything fancy. You just say it is an overestimate because it was an increasing function. That's all you need to say. So if it's an increasing function, what would a left side give you? That would be an underestimate. So they are assuming a certain level of understanding. So you don't have to be, because it's a right side sum and it's an increasing function, although that would be safer. Okay, part C. Nathan skates on the same track, starting 5 feet ahead of Kathleen. Nathan's velocity is given by this crazy function n right here. Oh boy, right, but don't evaluate. Woo! Where Nathan is. So let's figure out where is Nathan. So what happened here? What's the first thing? Where did he start? 5 ahead. So we better start there. Boom. Plus integral from 0 to 12 of ugliness I guess that's it. I guess I'm kind of finished. I just was supposed to write it down and nothing else. And it says, oh, and this would be Nathan's position at t equals 12. So we might want to write a little story to say we understand what that means. And then let's figure out Nathan's acceleration. Now, oh, shoot. I know Nathan's velocity. How do I find Nathan's acceleration? Oh boy, we get to do a little derivative. They actually don't frequently have just a straight off do the derivative on the open response. So what rule do we use to find this? Okay, so low d high, then what? Minus high, d low, what's d low? Just 1. Square of what's below. Okay, so it looks to me like this is 0. I got a negative 150 over t plus 3 squared. Cool so far? And then over here, what happens when I take the derivative of this? So remember that the derivative of e to the u is e to the u du. So what is the derivative of the negative t part? Just negative 1. So we do have a double negative, don't we? So plus 50e to the negative t. And that is the end of problem number 3. You guys, was that one a better one? I think a lot of you probably like that one a little bit more. So let's go ahead and take a look at the answers on that one. So when we got into that one, it looks like you got a point for your estimate and a point for your units. Part B, you got a point for your right sum, a point for your approximation with units, and a point for your reason about your overestimate. So notice they said it's an overestimate since it's a right Riemann sum used and it's increasing. So then going down a little bit, 1 point for your integral and 1 point for your answer, which is kind of funny because the answer is mainly just the integral. But I mean, arguably you needed to put the 5 in there. And then last, they just gave you 2 points. Now, do you think they probably gave you 1 point for each of the independent derivatives that are sitting there? I think that would be the interpretation, but they did not specify. So that's, again, my interpretation. But they're just saying 2 points for your happy little integral. Now, I think when I was walking around, I saw most of you kind of like this fourth problem too. So tell me about this. So I personally I kind of assembly lined the thing. Everywhere where x was 0, what's the slope going to be if x is 0? Yeah, so I just went through here and I went bank, 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 bank. And then I said, well, okay, so then I guess I did 1, 0, and I made a little key off to the side. So what was the slope at 1, 0? I got negative a quarter. So I just kind of like, that looks pretty good to me. And then I went over to the other side at -1, 0, and I got positive a quarter. So I kind of went like, yeah, looks about like that. You guys all right with that? And then what was the slope at 1, 1? 1, 1 was it 0? Oh, that's funny. 0. And -1, 1 was also 0. So I just kind of made a little answer sheet off to the side. Then I went to 1, 2. What was 1, 2? I think it was a quarter again. So like this. And then at -1, 2, I think it was negative a quarter. There's symmetric. And then it goes to a half on this side and -1/2 on this side. And so then we come in there and they say, oh, hey, let's move on here. And it says, let y be the particular solution of this. So they gave me a coordinate 1, 3. They gave me a coordinate 1, 3. And what did you just find was the slope at 1, 3? They told us, you just told me that the slope was a half. That's all we had to do. And it says, oh, could you use this thing to figure out what happened at 1.4? So what is 1.4 minus 1, everybody? 0.4. Half of 0.4 is 0.2. So what is y about? 3.2. So this is one of those problems where, honestly, if you got bit by that, I'm actually okay with that because you're like, okay, I'll get that one next time because that was an easy problem. I hope they give that to me. That happens. So it's all good. Now, this is actually the big problem. This is the one that I wanted to see happen because we know that dy dx is this. So without even looking at the answer key already, you guys should know that over at the side, they're going to have a note that says 0 points if what? If you don't separate, we're not going to read it. Okay, so that's really critical that you separate. So what is going to be on the dy side and what's going to be on the dx side? Who can help me with what's on the dy side? It's going to be 1 over y minus 1 or y minus 1 to the minus 1. That's fine too. What's going to be on the dx side? Now, unfortunately, that is going to create a c on both sides, isn't it? So we're just going to bring the c's together and just call it c, right? So what is the integral of this? It is the ln of y minus 1. Integral of 1/4 x, 1/8 x squared plus big C, right? Now, it is an important point to mention that in all of these problems, all the y values for the particular solution 1, 3 are above 0, aren't they? You follow me? It's above the number 0, so I don't need to deal with the absolute value. If it was underneath, I would have to take the negative side of that because there should be an absolute. So here's where we get ourselves into a little bit of a pickle. When do you want to find C? Because some of you will choose to get it all isolated first and then go get C. Some people would want to plug in 3 right now and 1 right now and go get C right now. I personally tend to like to do this little trick because we have done it a few times, haven't we? So to me, that was easier because we have done that e to the ugly brings that constant down. You guys cool with that? And so what's the only thing left to do to finish this problem? What have I not done yet? I haven't found C. So we're going to plug in 1 for x. Well, what is 1 to x going to make right here? E to the 1/8. Honestly, I looked at that and I'm like, you people suck. They could have made that nice, couldn't they? Very easily given you a decent number that works, but they didn't. And what's it equal to? Says 3. So what are we going to do to get C alone? Subtract 1. Divide by 1/8. So C is 2 divided by e to the 8th. Cool? So that means my value of y, my particular solution would be 2e to the negative 1/8, e to the 1/8 x squared plus 1. Now, what if you had left an e to the 1/8 in the bottom? Fine, I don't care. It's going to be fine. There's nothing wrong with that. By the way, this answer and the other answer are not going to match the key because there's something kind of screwy. You guys remember back from basic algebra, what is x squared times x cubed? X to the 5th. When you have bases that are the same, see how you add the exponents? So you look right here. Are these the same bases? They're both e. So can I add the exponents together? So what they did in theirs is they added these together. And then one more thing, they said, well, they both have an 8th in common, don't they? So they factored that out. But I promise you, if you grab this one, they're going to be, of course, that's the smarter play anyway. If they're going to be flexible in what they would accept, why wouldn't we just leave it alone? Because see, all of this mess that you're doing from here to here, aren't you upping your chances of making a stupid mistake? And what do they read? The last thing you wrote. So if this is right and then you made a mistake, then you just had the point and you gave it back. And that's true for the final exam as well. So you want to be a little bit cautious about giving away what you've already earned. So here's our answer key. So you are going to get a point for all the zeros. So there's a T right going right here and right here. A point for all your zeros and a point for all of your non-zeros. You're going to get a point for your tangent line, which was right here. Now you'll notice they actually, this is funny, they actually went to a version. You guys notice that that's not exactly point slope? They just moved the 3 across and then 1 point for the approximation. But again, if you didn't realize that and you gave up these 3 points, no big deal, because here's the money. So number 1, if you separated, you got a point. You got 1 point for each antiderivative. You got a point for your constant C, and then 1 point for when you solve it. So now notice what they did for their answers. This is what I was saying, is they took that extra step, which was obnoxious, wasn't it? But I firmly believe from everything that I've been told that they would accept that answer that we started with. because it is equivalent, isn't it? And it's valid. There's nothing invalid about that answer. So I would say go with whatever one is the easiest for you. What's that? Absolutely. And in fact, Mr. Corpy, that's been actually very, very helpful to me to listen to some of his videos because he's literally been in the room scoring these things. And so he even tells his students all the time, if they get down to the end of the problem and it's 4 plus 5, he just tells them this is box 4 plus 5 and move on. Don't even write down 9. Don't even bother. Because if your work is correct and your answer is equivalent, you're good to go. Okay, now if you separated wrong, they technically will read with you as long as it is reasonable. Now, the reason I say that is a student, they're smart people. So let's say it was a really, really hard problem and you're like, blah, blah, blah. Okay, so I don't really know what to do on that. So you wrote the integral of x squared equals 1/3 x cubed plus c. So you wrote a good problem and you solved your problem right. If there's no connection between your problem and that problem, they're going to say, thank you for playing. But if you made an honest mistake within the realm of the question, they will read with you. So your separation, you did separate it. Ooh, you probably would lose a point for your separation because you separated wrong. But if you integrated both correctly, they would read with you. You just slowed the grader down a lot and they're probably irritated, but you know, it is what it is. Okay, so how are we going to find R? Now, this is actually an interesting one for me because what did they do that was so nice? That doesn't normally happen. They gave you the points of intersection. Did they need to do that? I bet you anything what happened is they went through the test and they figured out, oh crap, this thing is getting a little long. That weird implicit derivative that we had earlier on this problem took some extra time. So let's give them something extra, because could we have taken this? Could we have solved that? Could we square both sides and just do a little quick math and come up with 0 and 9? But they saved you a little bit of time. So how do we find the area in here? So how do we set that up? Top minus bottom. Who is top? Root x minus bottom, which is x over 3. Dx, and where do we want to execute that from and to? From 0 to 9. Now again, power rule is something I've told you to embrace, right? Instead of thinking of that as a square root of x, what do you want to think about as x to the half, right? So if you think about this as x to the half, we're going to do our antiderivative. What about 1/3 x cubed? What's that going to be? What is it, everybody? 1/6 x to the second from 0 to 9. Now, really, really nice that they put 0 as one of our values. Sweet. Don't have to do it. Awesome. Not going to have anything. So I just need to figure out what is 9 to the 3/2 power. What is that, everybody? Well, 9 to the 1/2 is 3. Cube that, I got 27. Bummer. What is 9 squared? 81. Could I leave it right there? Yes, you could. You would be absolutely within your rights to do that, but if you kept going, it is 9/2. All right, number 5B, it says write, but don't do it. Write it, but do not do what it would actually be to actually do that integral. So keep in mind what we have is we've got the two lines. We've got this thing up here, which is y equals 4, and we're going to revolve that thing around that line. Oh, boy. So what is this distance right there? From 4 down to that. Did anybody figure out what that distance was? Because this is x over 3. It's 4 minus x over 3. So that is pi r squared. What about this one right here? That's 4 minus the square root of x. So remember, all we did is we did the inside and the outside, and we subtracted them. And where do we want to integrate from? 0 to 9. Don't forget your little dx. That's it. They said write it, don't bother to do it. Now, why did they say don't bother? You don't have a calculator, that would suck. Could we do this one? Actually, we could do that one too, but that would be evil. We could execute that, but the time would just be bad. And here's probably the one where people are right on the cusp of getting it, but if they ever say, let's find the maximum distance, this is really important that you know. When you do those problems, you have to actually consider several things. So I'm going to write x here and distance here, but one of the rules that I gave you is it says, let's find out the maximum distance between 0 and 16. So you always have to start with the beginning and the end. Now, by the way, if you plug in 0, that doesn't sound like a max distance, does it? If I find the distance at 16, in other words, I took 4 minus 16 over 3. By the way, this is the square root of 16 minus 16 over 3. This is 4/3. Well, that's certainly bigger. But what do we do? In addition to finding the beginning and the end, there's one other thing that we're supposed to do. We're supposed to take d of x, which is the distance between them. You guys okay with that one? That's the distance between them. Now, technically, it's in absolute value, okay? It's possible that one's on top and one's on the bottom. That's okay. What do I need to do? This is where the calculus is. How do you find a maximum or a minimum? Think about a curve. Where is a max or a min going to be? Take the derivative, set it equal to 0. Now, of course, how would you guys solve this? Let's add 1/3 to both sides. Let's cross multiply. What would you guys do next? I personally just square both sides. And so what does that make x? 9/4. So the place where that derivative would be 0 is at 9/4. Now what I've got to do is I got to plug 9/4 into these two values. So what is the square root of 9/4, everybody? It's 3/2. Think about it. The square root of 9/4 is 3/2. And then if I plug in 9/4 here, what is 1/3 of 9/4? See, normally I wouldn't say you'd have to even finish. You can just stop. But I need to know who's bigger between these things, right? So this is 3/4. So what is 3/2? 6/4. Minus 3/4 is 3/4. Where is the distance the largest? 16. The end point was actually the biggest. So it looked like it was the biggest in the middle, but because they allowed it to carry on past the number 9 where they crossed, they kept separating out there to the side. So here comes your answers on that one. Let's go ahead and reshare that. Here's your points. I know some of you guys will have some places where you're just kind of writing stuff down, but you got a point for your integrand, the stuff you put in the middle. 1 point for your antiderivative, where you actually did the integral, so you wrote it down, you integrated it, and 1 point for getting the answer. But notice they even wrote this right here. You could have stopped here. For part B, 2 points for the integrand. I'm guessing, again, 1 for this, 1 for this, 1 point for the limit and the constants. So what if you screwed up and you still got the pi and 0 to 9? You still got that point. And then the last 3 points come from here. So I took the derivative and I set it to 0. Now, by the way, did it say you had to solve it? No. If you took the derivative and you set it to 0, you got 1. If you figured out the number 9/4, you got that one. And then you had to come up with your answer and justification. So, of course, if you never considered 0 and you never considered 16, you are not going to get that part. But that's the cool thing is what did you still get as 2 out of the 3, right? Even if you forgot that you're also supposed to look at the endpoints. That was actually a kind question. And Our last problem, number 6. Sorry, I know this takes a little bit to do, but just where we are. Number 6, here's my function g. Let f be defined as this. What is f of 26? So what would f of 26 is the integral from 0 to 26 of this ugly mess right here, right? So how would you guys integrate that? I did a u sub, which technically is kind of silly because what would you call u? And honestly, I really liked it, but you can see the silliness right there because then du is dx. It's like, what? There's not much there. So what did you make this thing then? That's u to the minus 2/3. What's dx? du. The 4 is still hanging, but careful. If you made u x plus 1 and x is 0, what does that make u? 1. And if you made x 26, that makes u 27. Now, at first you might be like, okay, why did they pick 26? They picked it because why 27? Oh, it's a really nice number. Yeah, we go up 1, we divide by that new thing, which is going to put, remember we are going to divide by that new exponent, which is a 3, right? Careful about that. Divide by that 1/3. It's like multiplying by 3. From 1 to 27, do some math. The number 24 pops because we're going to take the cube root of 27, multiply by 12, and then the cube root of 1 and multiply by 12. And now they said, let's determine the concavity. How do you do the dang concavity? What is that? The derivative, but it said the concavity of f. But be careful. What is f? F is the integral of g. So you got to be a little bit careful because if f is equal to this, then what is f prime? That's g of x. That's called fundamental theorem of calculus part 2. And so what is f double prime? The derivative of g. So we need to now go find the derivative of g. So if g itself was 4 blah, 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 so this isn't going to be too bad. What's the derivative of that? I got first thing, negative 8/3, x plus 1 to the negative 5/3. Now, here's the part that's a little bit interesting. You don't really have to do this, but I chose to do it because that means this is x plus 1 cube rooted to the 5th power, right? Did you have to write this? No, I just felt it would be easier. So as long as x is positive, what kind of root are we going to get? You're going to get a positive answer, right? So I got a negative 8 divided by a 3 times a positive answer. So as long as x is positive, what's going to happen? I'm going to get a negative. So I would say G is concave down for all x greater than 0. And it says justify your answer since I guess I could say the cube root of x plus 1 to the 5th is always positive for x greater than 0. So I might kind of make a little statement that I recognize that that part is positive, but that other part was negative. And I believe this is the last question. And they did it again. By the way, if you didn't catch this before, I'm hoping you're catching it now. If they ask you for a minimum value, how do you find maximum and minimum values every time? You check the derivative equal to 0, but what else? The ding dang endpoints. So it says from 0 to 26. So we need to figure out what is actually happening at the endpoints, 0 and 26, but we also have to find out where the derivative is 0. So at 0, what was h of x? Well, I think I need to go back and look at what the original problem was. So if H is X minus F. Now, guys, this is an amazing problem. What is this? The integral from 0 to 0 of gx dx. 0. And if you plugged in 0 for x, what did you get? Okay, that was pretty sweet. That was pretty nice. And then we have 26. H of 26 would be 26 minus the integral of 0 to 26 of g of x dx. But did we already find that value a minute ago? We did. We found out that that value specifically was 24. So this is 2. Now we're finding the minimum value. So far, what's the minimum? 0 it is. But then the last part of finding a minimum is taking the derivative. So what is the derivative of h? So what's the derivative of this part? 1. The derivative of this would be g of x itself. So if I want to plug in this thing and set it equal to 0, I want to know when, I got to remember exactly how I did all this. I set that equal to 0. So it was 1 minus 4. X plus 1 to the minus 2/3 is 0 because we already did the derivative earlier. That is x plus 1 to the minus 2/3 is equal to 1/4. That's x plus 1 is equal to 1/4 to the negative 3/2, which turns out to be 8, and x is then 7. Boy, that was some stuff, wasn't it? That was rough. And this is the last question of the test. So that I felt like that was kind of mean to make somebody do all of that to get x equals 7. And by the way, you're still not done. Because what are you supposed to do now? You got to plug it back in and find out what h itself was. So if I plug in 7, I got a 7 right there. And then I've got, oh, now I got to do the integral from 0 to 7. And that's when I, like, you guys were working, I did my own thing, and I did this problem. I'm like, oh, they were mean. The integral from 0 to 7 makes you start all the way over. We don't know that. We basically have to repeat the work that we did, in this step right here for 0 to 7. Doesn't that mean? Jerks. Anyway, when you do all of that, you get negative 12. I'll spare you the details because it's literally repeat part A. It really blew me away that they did that. They were nice in this one place, and then that was just concentrated mean because they made you do this extra thing. So which one is the minimum value? Negative 5 is the minimum value because it's the lowest of all of the above. And so we'll do our score, and then I'm going to stop talking because I'm tired. All right. Anyway, so the scores. Score. Here we go. If you did your antiderivative, you got 2 points. I find that funny. 2 points this time for an antiderivative. Probably because it involved a use of, and 1 point for your answer. They gave you a point for f prime, realizing it was the function. 2 points for f double prime. Another point, sorry, for f double prime, and then a justification that it was always concave down. And then a bunch of points for here. So if you found h prime and you set it to 0, bing. If you figured out that 7 was a candidate, bing. And 1 point for your final answer. So go ahead and catalog all of that stuff all together. And so remember, it was multiple choice times 1.2 plus all of your free response. 1.2 times your multiple choice total. I'll give you a moment.
I would round down. Yeah.
Okay, now for some silly reason that I do not know is they did not actually provide me the scoring guidelines grand total for this particular one. which is really frustrating because I have everything else that I could want. In fact, to the point where they broke it down. This is from College Board. They actually broke it down over here to say, what is ROC? That's rate of change. Area is the accumulation. Remember, the integral is the accumulation of the area. See, they put all of these things in and kind of told everybody where all of those things go. And they broke it down by standard, which is pretty nice. I don't think there's anything over here, but there it is. There's the score. So if you got a 5 is any score above 70, a 58 and above is a 4, a 46 and above is a 3, and then the 38 and above was a 2. So again, I know that this is a false story since you got to work together and our time frames were not exactly perfect. But get yourself an idea, and hopefully you're starting to feel like you're starting to see some things that you did not see the first time and growing a little bit. And boy, that makes me tired. So your homework for tonight, and because there is very little time left, but your homework for tonight is I've got 2 questions for you to do. They're taken from the 2016 practice test, by the way, because there is a practice test. This isn't the real one. So if you look up the real one, you won't see these. Sorry, no cheating. So you're going to try to do 2 problems. So it's literally a half an hour. That's it. And you should set yourself as a timer to take that half an hour. So that's all I'm asking you guys to do is a 30-minute homework assignment. I'm going to set it right here. Feel free to grab one. Feel free to start on it now and read it over a little bit, but you'll get yourself a half an hour's work when you sit down to do it. And Gian, I hope that helped. Probably a little bit long and boring just to go over answers, but I hope it worked. So I will see you guys later. Avery and Shane, do you guys have any questions for me before I sign off?